Now, I will explain our codes for our systems. First, we use Arduino C++ as our IDE and Firebase as our main database. There will be 3 codes that I've created. One is for the solar panel, second goes to hydroponics, the third goes to the controller. Now, I will explain the parts of the code. This code right here is to represent the library for the Firebase, which is essential to work ESP8266 to Firebase. This will be used to connect Wi-Fi for the ESP8266. This code right here will be connected to the server for the Firebase and the authenticator. This code right here will be used in the temperature sensor to represent the addresses of each. This code right here will represent the assigned digital pin for the multiplexer. This code right here will be a global variable will be used in the current sensor. This global variable will be used to transmit Firebase from the ESP8266 to Firebase for the temperature sensor. This global variable will be used for the voltage sensor. This global variable will also be used to transmit data from the ESP8266 to Firebase for the current and voltage sensor. This global variable will be used to the voltage sensor. This code will be used to verify if it's connected to the internet. This code right here will be to assign the pin for the multiplexer. So, we use multiplexer to expand the analog pin of ESP8266 because it has only one pin, and we use mini sensor for the analog. The multiplexer works by assigning 3 digital pins to correspond what channel is selected. This will be used for to define the addresses of the temperature sensor. We use 3 temperature sensor. One is for the top of the panel, middle, and bottom. This Firebase set string will be used to upload the data to the Firebase. Okay. I average them from the 3 temperature sensor. The change mux will be used to assign what channel is selected. So, if low 00 is B corresponds to channel 1. So, I use LDR to verify that our solar panel is hit by sunlight. This code right here will be the averaging for the two LDR. So in this condition, in conjunction with the temperature sensor, so we can confirm the temperature sensor is working properly in the sunlight, or it's not malfunction. To verify it's not malfunctioning. If the condition is met, if it reaches to 34 optimum temperature of 34 Celsius, then the cooling system will turn on. If it's not, it will be turned off. So for the channel 2, this code right here is for the current sensor. I use 150 samples to increase the accuracy of the current sensor and voltage sensor. This analog read is to read the analog input for the corresponding channel is selected. What analog channel is selected? I'll be using 3 current sensor, which will be the current in and current out of the in the battery, and current will be testing with the current without coating. Okay, this code right here will be used in the voltage sensor. The voltage sensor will be used voltage divider to calculate the voltage. So the R2, R1 and R2 will be specifically assigned for the voltage sensor. So you can check the data sheet for it. And this will be the voltage sense for the output, and this will be also used in the for the voltage input of our system. This code right here, the last code will be to verify as if the ESP826 is not connected or failed to connected. Now for the second code for the hydroponics, we'll be using ultrasonic sensor and the water level sensor for each tray of our hydroponics. And the ultrasonic sensor is to measure the level of our reservoir. This code right here is to assign the ultrasonic the pin of the ultrasonic sensor. This will be the global variable for the ultrasonic sensor. This global variable will be used to the PS sensor. We'll be using a PS sensor. I forgot, sorry. So the string will be used to help to transfer the data to the Firebase. This is to assign the output and input of the pin, and for the analog pin, this pin will be corresponds to the ultrasonic sensor. This code will be a specific code for the ultrasonic sensor to work properly. So this is to calculate our distance will be measured by feet. And now for the channel 1 of analog pin. This code is used for the PS sensor. It is a specific code for it. And this code will be used for the water level sensor for the 4 trays of our in the hydroponics, which will determine the water level for the 4 trays. Now I'll explain the last code for our solar controller, and we'll be using a timer to control the solar controller. Now this code is for the library. You must install it first in order to work. So this code will be to assign the relay, to assign the pin of the relay. So this code is to assign the pin for the timer, and also this. So this code, this 4 code is which will be used to assign the time to which time is to on the relay or off. So this pin mode is to assign the output for the relay. So this code is to specify what time or assign time. So this code represent the set time to on the relay, which will be to what we have input in it here. So this to specify what time to turn off the controller, which will be around, for us is around 6 p.m., which will be there no sunlight, and 9 a.m. to which will be the controller to turn on, which will get adequate sunlight for our system. Thank you for listening.